Hello everyone, I hope everyone is having a great day so far when they start watching this video. Today we're going to learn about some ions and isotopes. So, as always, I like to start asking some questions to get our brains thinking about our ions and isotopes. And I always, my first question I should say is what happens if we change the number of neutrons in an atom? So, we've learned that our atom is made of neutrons, protons, and electrons. So what would happen if we change the number of neutrons? And also what would happen if we change the number of electrons? So we said that our protons are always equal to our atomic number. We can't change that, but we can change our neutrons and electrons. So if we changed our neutrons, it would change our atomic weight, or vice versa. If our weight changed, our number of neutrons would change. If we changed our number of electrons, our overall charge would change. So we'll talk through some of that. So by the end of the day, I want us to be able to understand what an isotope is and how to calculate the number of protons, neutrons, and electrons in an isotope. And then the same exact thing for an ion. So the first things we're going to do is to define some of these. So an isotope is an element having the same number of protons and a different number of neutrons. So what that means is this will change our atomic mass of the atom. So if we have, if we have more neutrons than protons, or than normal, if we have more neutrons than normal, our weight will be more. Sometimes we will lose neutrons, so it'll be less than normal, but that's okay. So this will be, then when we write our isotopes, it'll be the number next to the name is going to be its atomic weight. So before we learned that we use our periodic table and the symbols and atomic weight from that to be able to calculate things, but this time we're going to use the number next to our element's name. So for example, carbon 13, normally carbon has a weight of 12, but carbon 13 is an isotope. And so we write 13 next to it because our periodic table would tell us that the weight is only 12. So our isotopes occur very naturally. And then the atomic weight that we use on the periodic table is actually an average of all the isotopes that we find naturally on Earth. So that's why we usually see a lot of decimal points. Something like hydrogen, I think hydrogen's atomic weight is actually 1.01. And that's because we can see over here we have a couple different isotopes. So normally hydrogen looks like this, where we have one proton and one electron. And so the atomic weight is 1 because we only have one proton. And the charge is neutral. Now we're going to have one proton, one electron, and one neutron. So our atomic weight is now 2, and we still have a neutral charge because we have just as many positives and negatives. This time we have one proton, one electron, but 2 neutrons. So this one is even heavier than our first example. But the way this works is with our averaging, the things that are found more naturally, that come up more often, is our normal proton. So because our proton normally comes up, maybe let's say 95% of the hydrogens you're going to find on the Earth look like this, but the other 5%, or the other maybe 2% look like this, and 3% look like this. That averages into how we find our atomic weight. So that's always why our atomic weights have some few extra decimal points, but the important thing is when we're doing an isotope problem, our atomic weight is given to us by putting it next to the name. We also have ions. So ions are really important. An ion is an electrically charged atom created by the gain or loss of electrons. So for our examples, we have them written. Instead of writing our normal element, we write sorry about that. Instead of writing our normal element, just cadmium Ca, we now have a charge next to it. So we have, it'll either be 2 plus, or maybe 1 minus, or 3 plus, depending on the charge. And how that works is, this occurs because I should back up. How this works is our atoms like to lose electrons or gain electrons based on how many valence electrons they have. So we learned last week about valence electrons. So for example, our sodium atom has 1 valence electron. So if it could somehow get rid of this electron, it would go back to having a full shell on the outside, a full valence shell. Right now it's unstable because it has just 1, and it needs to be either at 2 in the inner shell, 8 electrons or 8 electrons in an outer shell to be stable. So if it can lose an electron, it will. And we can see that this time a normal sodium atom has 1. As soon as it loses its outer electron, it is a stable shell now, but it becomes an ion, because by losing a negatively charged particle, we become more positive. So that's what we said here. We're stable at either 2 electrons or 8 electrons. The only time we're stable at 2 electrons is our first shell on our periodic table, our first shell in our atom. And then we become more positive as we lose electrons, just like in math. So if we subtract a negative number, it's like adding 1. Maybe I like to think of this sometimes as if we have someone in it who we work with or we are around a lot, who's really negative, who's really down, who doesn't really think about things in a positive way. If we don't talk to them for a while, we're going to be happier because we're more positive. So that's one way to think about it. Sometimes it helps to think about it like we do in math. So, and then this happens as changing the entire atom. This is not what is called a partial charge. It is a full changing. The other thing I like just to mention is we have special names for if an atom is either gaining or losing electrons. So if it is gaining electrons, we call it if it's losing electrons is a cation. If it gains electrons, it's an anion. But we're going to stick with just focusing on the word ion for now. So ions. So let's talk about how this will affect our way we find each one of our numbers. So we're going to work through this. So again, the number next to the element is the atomic weight. So our example is carbon 13 weighs 13 AMUs. So we're given carbon weighs 13. Our atomic number is always going to stay the same, regardless of if it's an isotope or an ion. Our atomic number always stays the same, and our number of protons always stays the same. Now, this is an isotope. We can know that by the way our name is written. So because it's still neutral, we don't see a +2 or a -1. We're going to have the same number of protons as we do electrons. And then we can find our neutrons the same way we have always found our neutrons, by subtracting our number of protons from our atomic weight to get our number of neutrons. So really, all that changed in our from our isotope to our normal carbon atom is our number of neutrons. The rest of them stayed exactly the same. So we can see our atomic number is the same as it was normally, and our number of protons and electrons are the exact same as they usually are. Let's look at an example for our ions now. So we have the number next to us tells us how many electrons have been lost or gained from the ion. Again, electrons carry a negative charge. So aluminum, or Al3+, has actually lost 3 electrons, not gained 3. So for our example, we see cadmium. This is a normal cadmium. We don't see a 2+ or a new weight next to it, so it's just Ca or cadmium. So our atomic number is 48. Our atomic weight is 112. Number of protons are always equal to atomic number. Number of electrons are equal to the number of protons because it's neutral, a neutral atom. And then our number of neutrons is equal to the atomic weight minus the protons. So let's see how it'll change for our ion. So our atomic number is going to stay the same. Our atomic weight stays the same because we are not changing the number of neutrons or protons. So our number of protons are going to stay the same. Number of neutrons are going to stay the same. And now the only thing that changes in an ion is that we have lost or gained electrons. So if we have a 2+, we are becoming more positive, so that means we are losing electrons. So instead of having 48 electrons, we have lost 2 electrons. Here, actually, let's do it this way. We have lost 2 electrons, so we subtract 2. Sometimes I even like to do it this way. If we would normally have 48, and we say we've lost 2, that means we would have 46 now. So the rest of this stays exactly the same. And we've been practicing how to find the numbers, all these quantities in a normal element. So for our cadmium, only thing that changes, our cadmium ion, the only thing that changes is the number of electrons. All right, so when I go through these, I like to think of the same procedure. So if we're given, hey, let's find this one, for any element, I like to go through the same procedure of saying, what is it? So let's identify if it's either just a normal element, a normal plane element, an isotope, which has a number next to the name, or an ion, which has a charge next to the name, so plus or minus. Let's find the number of protons or the atomic number, because those are always the same. They will always be the same. Then I like to find the number of neutrons and the atomic weight, because those are very closely linked. And then finally, I find the number of electrons. A lot of the times, the number of electrons is equal to the number of protons, but in ions, it's a little different. So we have to be very careful around ions. So we're going to do a lot of practice with these, so do not worry. But if you have questions, please let me know.